So today we start second order equations. Efendim? Hayır. Second order partial differential equations. We will consider uh, only linear equations, and therefore they have a well-established theory. So in this way, I mean, I guess it will be easier to comprehend, what is going on. Unlike first order equations, there we had different, so many different kinds of equations, and each one needs its own approach. But for second orders, we have basically three kinds of equation: heat equation, wave equation, and Laplace equation. And their theories are maybe different, but they follow the same pattern. We have existence, uniqueness theorems, and so on. So it is a much more established theory, and I think it will be easier to understand what's going on. So let's start with what's the first or second order equation and classification of second order PDEs. So this is second order partial differential equations, and the first thing we will do is classification of second order PDEs with two independent variables. So we will consider mostly two independent variables. So they will be x and y, independent variables. And z will be z xy, or sometimes we will use u xy or w xy is the dependent unknown variable. İşte heat equation olunca genelde U kullanılır. Wave equation'da W daha çok. So the general form of the linear second order PDE is as follows. Bir katsayı fonksiyonu and then del x squared. So second derivative of the unknown functions with respect to x, and then another coefficient function, and then derivative, second derivative with respect to x and y, and then c times second derivative of u with respect to the second independent variable y, and then first order terms d del u del x plus e del u del y plus fu plus g equals 0, where a, b, c, d, e, f, and g are functions of the independent variables x and y. Okay, so they are not scalars but functions of x and y. Therefore, no u term is in product form with another u term. Okay, the coefficients of u terms are only functions of the independent variables x and y. That's why we call it a linear equation. We will not consider, as I said, nonlinear equations because their theory is, much more difficult. You may spend your life to study one of them. And there are people like that. Ama yani bu heat equation mesela topolojide bile kullanılır, geometride kullanılır. Hani onlar sadece çünkü çok temel denklemler bunlar. O heat flow vesaire o tür şeyler hani sadece fiziğin değil, hani birçok şeyin temelinde olan şeyler aslında davranış şekilleri ve hani geometride de kullanılır, topolojide de kullanılır. Okay. Note that the equation can be written şöyle de yazılabilir. A u sub x x b u sub y y plus c u sub x y, sorry, u sub y y plus some function of x y u sub x and u sub y. Of course, this is something more general than this one because here, we may have product of u terms and so on here. So this is actually general than this one, but the thing is that the second order terms are, the dominant terms and they are linear. So no u term is in product with another u term. If they have second order derivative terms in them. Yani ikinci dereceden türevli terimlerin katsayılarında herhangi bir u yok ama burada u'lar birbiriyle çarpılabilir. Ona az çok izin veriyor. Dolayısıyla bu ondan biraz daha genel bir hal. Peki. Şimdi bunun classification of these PDs is similar to those of quadratic polynomials. Kuadratik polinomlar nelerdi? Hatırlarsanız işte şunlar: ax kare bxy artı cy kare artı dx artı ey artı f equals 0. Polynomial equation'lar. Tamam mı? Burada da classification nasıldı? Bu ikinci derece olduğu için bir konik verecek. Bu konik, so this is a conic in R2. It is either a parabola or an ellipse or an hyperbola, right? It is one of them. And so this is a conic in the plane R2, and classification is follows. It is a first an ellipse if what happens if the discriminant, what is the discriminant? It is EY, evet EY, özür dilerim. Discriminant o da nedir? İşte B kare eksi 4 AC, bu pozitifse, and hyperbola if discriminant, which is b squared minus 4ac, is negative, and parabola if the discriminant, which is b squared minus 4ac, is 0. Okay? Yani burada işte şeyse elips ise, bu elips şöyle bir şey olabilir, değil mi? Hyperbola, it can be something like this. Yani şöyle bir şeyde, işte atıyorum, şöyle bir şey olabilir. Parabola da şöyle bir şey olabilir. Bir tane ekseni vardır. O eksen boyunca şöyle bir nesne olabilir. Değil mi? Bu katsayıların durumuna göre işte ve şunların durumuna göre shift edilmiş olabilir vesaire vesaire. Okay, so this is something you know from 115. Okay. Artık olmayan dersimiz. İyi ki zamanında almışsınız, değil mi? Çok yazık oldu. Okay. Şimdi şeye bakalım. Bakalım. Kontrol edelim. Yani x kare artı y kare, bu elips A1, B1, yok, C1, D0, B kare, evet, eksi 4 AC, haklısın. So this is negative, this is positive. Okay, so here this should be negative, this should be positive. Sağ ol. 215'i almamışız, değil mi? Çakardık. Efendim? 115. Ben ne dedim? 111. Öyle mi dedim? Ha, 115 demişimdir ya. 215 diye bir dersimiz hiç olmadı çünkü. Tamam. Tamam. Olabilir demiş olabilir. Şimdi peki. So, kamera. Evet, o da kaldı. So let's denote this part of the equation, a u subset x, b u x y, and c u y y as lu. So we consider L as a linear operator. Whenever you give me a function, I just take its second derivative, multiply by a, take this derivative, multiply b, and so on. Okay, so this is a linear operator. And for short, we will just denote it like this by lu. Okay, then the classification is as follows. Here, of course, A, B, C are, as we said already, these are functions of uh, the independent variables. And let's say these independent variables live in some region, let's say, bu da yazmış mı? Omega diyeyim. Şöyle bir region olsun. Bu düzlemin bir alt kümesi. Peki, şimdi şöyle diyeceğiz. Definition. So the equation a u x x s and so on up to f equals 0 is called hyperbolic if this discriminant, let's say delta, which is b squared xy minus 4axy cxy is positive, hyperbolic at xy diyelim. At xy, if this is positive, we call it elliptic at x comma y. If this delta is negative at xy, and finally, we say that it is parabolic at xy if this delta is 0 at xy. Examples. U sub x plus u sub y equals 0. Here, a xy is just the constant function b, 1. bxy is the constant function 0. And cxy is the constant function 1 at any xy of the plane. So this is a equation defined on the whole plane, actually. And delta, which is b squared minus 4ac, is just minus 1, right? This is 0, these are 1. So no, minus 4, which is always negative. So it is negatif olduğuna göre elliptik. Elliptic at all points of the plane. Bunun adı önemli bir equation. Bunun adı Laplace equation. Elektrikçilerin en çok e, uğraştığı denklemlerden biri. E, Yani 2 haftada bu bir kısmı yapılıyor. Aslında biz de yapıyorduk da biz şimdi onu ayırdık. Hani şimdi çıkardık onu PD'ye koyduk çünkü biraz aynı şey bir daha yapılıyor gibi oluyordu. E, O yüzden. Da hani o kadardıktan şeyi öğrenemezler. Hani o e, bayağı kapsamlı bir şey. UT UXX heat equation. So here uh, L is just this, right? So A x y is just 1, b x y is just 0, and c x y is just 0. So delta, which is b squared minus 4ac, this is just 0, and hence the equation is parabolic at all points. Bu da wave equation. So here the independent variables are not x and y, but t and x, okay? T representing time, x representing the position. So this is a one-dimensional wave equation. X is the position, and t is the time. So you in the xy xty plane, yani işte şu dalganın yüksekliği, ama zamana göre bu fonksiyon değişiyor, tamam mı? U is this, let's say this is the wave, but here depending on t, this wave is changing. Here a is just 1, let's say a is this coefficient, b is 0, there's no cross term, t is -1, right? So delta is just b squared minus 4ac is just positive. Therefore, this is hyperbolic. Hence, it is hyperbolic. Evet. Tabii tabii. Mesela şu. X sıfır olmasın. Yani domainimizde x'in sıfır olmadığı yerlere bakıyoruz. Dolayısıyla ya x eksenin üstü ya da altı. Hani orada çalışıyoruz. So either we work here or here. Okay? No. Not like this. I'm sorry. Okay, so A is 1, B is 0, and C is just X. So delta, which is B squared minus 4AC, is just minus 4X. And this is sometimes positive, sometimes negative. So this is positive if X is negative. So it is positive here. Therefore, since it is positive, it is elliptic. So here elliptic. X negatives. Tamam, hyperbolic. Tamam, hyperbolic. And this is negative if X is positive. So here it is elliptic. So it's a wave equation here, Laplace equation here. Okay. Tabii. Kaldırmamışım. Şey olursa, daha fazla değişken varsa, if we have more than two independent variables, let's say, you know, X, Y, Z, then we will have, so if U is something like this, and we have three independent variables, then of course our LU will be something like this. A, let's say UXX, B UXY plus D UYY plus D UX Z ya da ZZ plus D UXZ and EYZ. E and F. Okay, so we will have this, and this time we will consider conics in three variables. So we should consider conics like this: ax squared plus bxy plus cy squared plus dz squared plus e xz plus f yz equals plus g equals 0, let's say, a conic. Okay. Üç bilinmeyenli koniklerin classification'ı o zaman yapacağız. So how do you do this? You write this in the following form, right? So you write here x, y, z, and then a, b over 2, Yes, E over 2 and then B over 2 C Y, Z'nin katsayısı F over 2 and then E over 2 F over 2 and D here, X, Y, Z, right? So this part is just equal to this matrix multiplication, right? So quadratic form written like this in matrix form. And then the classification just reduces to the classification of this symmetric matrix. It's a symmetric matrix. Therefore, it is diagonalizable. And the eigenvalues are all real. So in the diagonal form, you will have something like this. Let's say X, Y, Z. So after a base change, maybe I should say X prime, Y prime, Z prime, new coordinates. This matrix becomes something like this: lambda 1, lambda 2, lambda 3, and 0, 0, 0. Yok, şöyle. Right? X prime, Y prime, Z prime. So our new equation is just what? Lambda 1 X prime squared, lambda 2 Y prime squared, and lambda 3 Z prime squared. Plus something. İsterseniz bunu şey diyeyim, hani eşittir C diyelim. Şurada şöyle bir şey olacak. C prime. Bu da so depending on the signs of this eigenvalues, whether they are positive, negative, or zero, you get different kinds of conics, right? If they are all positive, then it's an ellipsoid. In this case, we will say that the equation is elliptic. If one of them is negative but the others are positive, then this will be an hyperboloid and the equation will be called hyperbolic. If some of them are zero, we will call it parabolic and so on. Okay. So şöyle yazayım. If lambda I are all positive for all I, then it is elliptic. B, if some lambda I are zero, hepsi sıfır olması gerekmez. Then it is parabolic. And C, if some lambda I are negative or positive, and all the remaining ones, ya aslında şey demek lazım. Eliptik veya parabolik değilse hyperbolik. Değil mi? Öyle demenin bir anlamı yok yani. Evet. Hepsi pozitifse eliptik. Birisi sıfırsa parabolik. Diğer hallerde hyperbolik. O ne demek? Efendim? Yok. Some dedik. Hani birden fazla da olabilir. Bir tanesi, iki tanesi sıfırsa eliptik. But otherwise hyperbolic. So hyperbolic means all the eigenvalues are non-zero, but some of them are positive and some of them are negative. Okay? They don't have the same sign. Tamam mı? 5 tane var. İkisi pozitif, üçü negatif veya biri pozitif, dördü negatif. İşaret değişiyorsa hyperbolik. Birisi sıfırsa parabolik, hepsi pozitifse eliptik. Tamam mı? Ee, olabilir. Ben o kadar anlamıyorum işin açıkçası. Ee, yani çözümün doğası onlarla alakalı oluyor olabilir ama çok emin değilim yani. Bir şey söyleyecek durumda değilim. Şunu biliyoruz ama hani denklem eliptikse genelde e, hem daha iyi anlaşılmış oluyor hem de daha kolay çözülüyor. E, parabolik olanlar biraz sıkıntı. Hyperbolik olanlar sıkıntılı. Yok, şey yok onlarda, sıfır yok. Şimdi hı, canonical and normal forms. Okay, now consider the general linear second order uh, equation a u x x plus b u x y plus c u y y plus d u sub x e u sub y plus f u plus g equals 0. These are functions of x and y, but I would like to replace these functions, if possible, by scalars, okay? So that it will look like under a variable change, usual heat equation or wave equation or heat equation, Laplace equation, sorry. So consider new variables C and new. Şöyle x ve y'nin yerine bunları yazacağız. Bunlar x ve y'nin fonksiyonları olacak. Let's write the equation in the new independent variables. C and mesela örnek example işte C and new şu olabilir. Yani x, y bizim kartezyen koordinatlarımız. C'yi şey seçebilirim. R bu x squared plus y squared and then square root and new da theta bu nedir? Tangent inverse y over x. Tamam mı? İşte bu x ve y'nin bir fonksiyonu, bu da x, y'nin fonksiyonu. Ne yapıyoruz? Kartezyen koordinatlarda verilen denklemi polar koordinatlarda yazıyoruz, right? So here, if an equation is given in Cartesian coordinates, using these transformations, we can write it in the new coordinates r and theta. So it becomes a equation in the polar coordinates. Why do we, do something like this? Well, your region might be like this, okay? You want to solve equation in this circle, then polar coordinates is, advantages here because it is easy to describe this region in polar coordinates. What is this? This is just r is between 0 and let's say 1, okay, in the r theta coordinates. So depending on your problem, it might be useful to work with another coordinate system. But now what we are going to do, we wanna replace this coordinates x and y so that a, b, c becomes something simpler, okay? They may be complicated functions of x and y, and we want to replace them by, if possible, by constants, okay? We will see if we can do that. Okay, now let me rewrite here again. C is a function of x and y, and nu is a function of x and y. And I want to replace derivatives with respect to x and y with derivatives with respect to these two new variables. Let's see how we can do this. Now, u sub x. So this is the derivative of u, right? U is a function of x and y with respect to x. I can write it this way. This is just derivative of u with respect to c, and then derivative of c with respect to x plus, well, so here u is a function of x and y, but I want to consider it as a function of c and nu in this new coordinates. So, and c is a function of x and y, and nu is a function of x and y. So to compute this derivative, I have to also consider the derivative with respect to nu, and then derivative of nu with respect to x. So what is this? This is u sub nu c, u sub c, c sub x, and then u sub nu and nu sub x. Similarly, u sub y will be what? It will be just u sub c, cy plus u sub nu, nu sub y. And then derivative of x, no, u with respect to x one more time. So this is just derivative of this with respect to this gadget. So this will be what? Derivative of this with respect to şunun ne olduğunu yazdık zaten. Okay. This is just u sub x sub x, u sub new sub x, and you want to take x derivative of this. These are all functions of x, so we apply Leibniz rule. Derivative of this gadget with respect to x. It will be as follows. Derivative of this with respect to xi and then xi sub x plus derivative of this gadget with respect to new and new sub x multiplied with this plus this gadget times derivative of this with respect to x, which is xi sub xx, and then we have the same thing here. So derivative of this with respect to xi and then xi sub x, derivative of this with respect to new sub x times new sub x plus u sub new and then new sub xx. Okay. So this is u sub xx. İsterseniz onu şöyle bir yazayım. U sub xx ne oldu? So u sub xx is this. U sub, okay. C sub x squared, u sub c, and then plus I have this term and this term, and the coefficient is new x, cx, and cx new x. So I have 2 of these. I assume that u is differentiable enough so that partial derivatives of u commute. They are equal. And then we have what? No, new sub x squared, new, right? This term. And then I have also this 2 plus okay. Şimdi şey göreceğiz hani ya bunu herhalde yapmak sorun değil. Chain rule. Birkaç tane hani böyle yaparsanız eliniz alışır. Efendim? İyi, ara verelim. Aradan sonra devam ederiz.